Hello, in this lecture we'll find out the length of line segment X using two different methods. In the drawing we have a quarter circle, AFE is a quarter circle. Inside this quarter circle we have square ABCD. We know that line segment DE equals to 12 units in its length. And this is angle GDC that is equal to theta, and angle EDC also equals to theta. And our mission is to find out the length of this line segment GD that is equal to x. So we have to find out the value of x. It is the length of this line segment GD. So we start with the first method, and first of all, because of the fact that ABCD is a square, all the four angles inside this square are right angles, so I write it down in this angle equals to 90 degrees in its size. This angle also equals to 90 degrees in its size. This is also a right angle. And finally, this is also a right angle. So it is equal to 90 degrees in its size. So what is the size of angle ADE? What is the size of this angle, angle ADE? It is very easy to see from the drawing that angle ADE equals to the big angle CDA, that is 90 degrees, minus this angle that is theta. So this angle ADE in total equals to 90 degrees minus theta. In the next step, we will do a construction. That is to say, we'll extend line segment GD and line segment EA by a straight line until they touch each other. And we define their touching point, this point, as point H. In the next step, we'll extend side CD of the square ABCD by a straight line. Extended this side CD. We created here two vertex angles, and we know that vertex angles are equal to each other. But this vertex angle is theta, therefore this vertex angle must be also equal to theta. We define this point as F. So this angle must be also equal to theta. So CD is one side of square ABCD, therefore it is absolutely a straight line. And we extended a straight line CD by a straight line, the result is CF. When we extend a straight line by a straight line, the result must be a straight line, so CF is a straight line. So if we focus on the lower side of this straight line CF at point D here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the lower side of CF at point D? We have this angle that is a right angle plus the missing angle. In total the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. Therefore this missing angle must be equal to 90 degrees in its size. In order to complete the sum of the angles at the lower side of CF at point D to 180 degrees, this missing angle must be equal to 90 degrees in its size. So the big angle FDA, this big angle FDA equals to 90 degrees in its size. So the big angle FDA minus this angle theta must be equal to this missing angle, that's actual angle ADH. So the angle ADH equals to 90 degrees minus theta. Here we extended the straight line EA by straight line, and the result is EH. So EH must be also a straight line. If we focus on the upper side of the straight line EH at point A here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the upper side of EH at point A? We have this angle that is 90 degrees plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. Therefore, this missing angle must be equal to 90 degrees in its size. So, in the next step, we will prove that those two right triangles can go into each other. That is to say, we will prove that the right triangle ADH, this right triangle, can go into this right triangle, triangle ADE. So why those two right triangles can go into each other. First of all, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So this is angle ADH, that is equal to 90 degrees minus theta. ADH, angle ADH in triangle ADH, and it is equal to this angle, this is actually angle ADE in triangle ADE. Repeat again. Angle ADH in triangle ADH equals to angle ADE in triangle ADE. They are both equal to 90 degrees minus theta, therefore they are equal to each other. In addition, this is side AD, that is a common side, it belongs to both triangles, so side AD equals to itself. Repeat again, side AD equals to itself is a common side that belongs to both triangles. And finally, those two angles are both equal to 90 degrees, therefore they are equal to each other. So actually, this is angle AD in triangle ADH, and it is equal to this angle, that is actually angle EAD in triangle ADE. So I repeat again. Angle AHD in triangle ADH equals to angle EAD in triangle ADE. They are both equal to 90 degrees, therefore they are equal to each other. So actually proved that the right triangle ADH congruent, this is the sign of congruent, to the right triangle ADE according to angle side angle rule. So what is angle side angle rule? Angle side angle rule is that if you prove that two angles and the side that included between the two angles in one triangle are correspondingly equal to two angles and the side that included between the two angles in a second triangle, then you actually proved that the two triangles are congruent to each other according to angle side angle rule. And we actually proved that those two angles and the side that included between those two angles, that is actually side AD in triangle ADE, are correspondingly equal to those two angles and the side that included between those two angles, that is the same side AD in triangle ADH. Therefore, we actually proved that those two right triangles can go into each other according to angle side angle rule. And from the fact that those two right triangles can go into each other, we will derive that side DE in the right triangle ADE is equal to side DH in the right triangle ADH. So I write it down and derive that DE equals to DH. Once again, we derive that D equals to DH. But D equals to 12 units according to what is given us the question. So we can write here that D equals to 12. And from this equation, 12 equals to DE equals to DH. We derive the side DH. The side DH is also equals to 12 units in its length. So here, this is side DH. That is equal to 12 units in its length. Likewise, according to the same rule, we will derive from the fact that those two right triangles can go into each other, that side AE is equal in the right triangle AED is equal to side AH in the right triangle ADH. AE equals to AH. Side A equals to side AH. But what is the definition of a side AE or line segment AE? Line segment AE is actually the radius of this quarter circle. So we define the radius of this quarter circle as R, and therefore AE equals to R. So I write it down here. According to our definition, AE equals to R. And from this equation, R equals to AE equals to AH, we derive that AH is also equals to R. This is side AH, that is equal to R. In the next step, we'll join points G and E together by a straight line. By joining points G and E, we created the right triangle, triangle EG. It is not a right triangle. We don't know if it is right triangle or not. We created triangle EGH. This is triangle EGH. We join points A and G together by a straight line. What is the definition of line segment AG? Line segment AG starts from the center of the quarter circle that is actually here at point A and ends at point here at point G, that is a point on the quarter circle itself. This is exactly the definition of a radius. Therefore AG is the radius of this quarter circle that is equal to R according to our definition. So actually this point A is the circumcenter of this triangle, triangle AG. In this point A is the circumcenter of this triangle, triangle HGE. So I write it down. Point A is the circumcenter of the right of triangle HGE. That is to say, the distance between point A and the three vertices edge G and E of triangle HGE are equal. Here you can see that the distance from point A to point H, that is the vertex of triangle HGE, is R. Likewise, the distance between this point A and the vertex G of triangle HGE is also R, because AG equals to R. And finally, the distance between point A and the vertex E of triangle HGE is also R. For that reason, point A is defined as the circumcenter of triangle HGE. And actually point A is also the center of the circle that blocks this triangle AGE. I repeat again, point A is also the center of the circle that blocks this triangle AGE. So I will write it down. Point A is also the center of the circle that blocks triangle HGE. But we know that any circle that blocks triangle HGE must pass through its three vertices. That is to say, it must pass for the vertex H, for the vertex G, and for the vertex E, of this triangle HGE. Okay? So it must pass for point E. And therefore, the radius of the circle that blocks this triangle HGE will be equal as follows. We know that point A is the center of the circle that blocks triangle HGE, and point E is the point on the circle itself, because the circle that blocks triangle HGE must pass for point E. This is exactly the definition of a radius. Therefore, AE is the radius of the circle that blocks triangle HGE. And AE equals to R, according to what we have already found out. AE equals to R. And therefore, in conclusion, we can say that the circle that blocks this triangle HGE, the center of the circle is at point A, and the radius is R, and also the must pass for its three vertices, that is to say from point H, G, and E. That is from one side. But from the other side, if we complete this quarter circle to a circle, we'll get a circle. Here, we'll complete this quarter circle to a circle. And if we complete this quarter circle to a circle, we will get a circle that its radius is also R, because the radius of the quarter circle is R. Therefore, the radius of the circle that will be created by completing this quarter circle to a circle must be also equal to R. And the center must be also at the same point, point A. So we have two circles with the same radius and the same center. The center is A, and the radius is R. So two circles with the same radius and the same center, they are not two circles, but one circle. Okay, again, two circles with the same radii and the same center, they are one circle, not two circles. So therefore we can conclude from what I've said here that the circle that will be created by completing this quarter circle to a circle, it also blocks this triangle AGE. And therefore it must pass for this point H, because point H is one of this of the three vertices of this triangle AGE. Repeat again, the circle that will be created by completing this quarter circle to a circle also blocks this triangle AGE, therefore it must pass for point H, that is the vertex, one of the three vertices of this triangle AGE. Okay, so we complete this quarter circle to a circle, and the circle must pass for point H. So you can see the circle that that will be created by completing this quarter circle to a circle passes through this point H, that is one of the vertices of this triangle AGE. So what is the definition of line segment edge AE? Because of the fact that angle edge AE, this angle edge AE equals to 180 degrees, 90 degrees plus 90 degrees is 180 degrees. Actually, any angle that is equal to 180 degrees in its size is defined as a straight line. Therefore, edge AE is definitely a straight line. But edge AE is a straight line that touches the circle at 2 points, here at point E and here at point H. Any straight line that touches the circle at 2 points is defined as a chord. So edge AE is a chord, but edge AE is a chord that passes through point A, that is the center of the circle, and we know that any chord that passes through the center of the circle must be the diameter of the circle. Therefore, edge AE is the diameter of the circle. If edge AE is the diameter of the circle, edge E is also the diameter of the circle. So I write it down, actually arrive to the conclusion that edge E, line segment edge E, is the diameter of the circle. Well, in the next step we'll focus on this triangle edge GE. This triangle edge GE, we have this angle edge GE. Edge GE is defined as peripheral angle, and this peripheral angle edge GE is subtended on edge E, that is the diameter of the circle. You know that any peripheral angle that is subtended on the diameter of the circle must be equal to 90 degrees in its size. Therefore, this peripheral angle edge GE must be equal to 90 degrees in its size. In the next step, we will focus on quadrilateral ADGE. Repeat again, we will focus on the green quadrilateral ADGE. In this green quadrilateral ADGE, those two opposite angles, they are both right angles. The sum of two right angles is of course 180 degrees. And you know that any quadrilateral that the sum of its opposite angles is equal to 180 degrees is a cyclic quadrilateral. That is to say, this green quadrilateral ADGE can be blocked by a circle, because the sum of those two opposite angles is equal to 180 degrees. So we will block this quadrilateral by a circle. So the red circle blocks this green quadrilateral ADGE, well, because it passes through its four vertices A, D, G, and E. Now we can implement in this red circle rule 12. I'll repeat quickly on rule 12. According to rule 12, first of all, rule 12 is true in any circle. So in any circle, if we have here code BA, the extended code BA touches the common sum point B, we have also here code DC, the extended code DC touches point P. So both two extended codes, A, B, and C, D touches this common sum point B. So in this drawing, the following equation is true, that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. We actually can implement rule 12 in our drawing. Why? Because in our drawing we have here we have code GD, and the extended code GD touches the common sum point edge, and we also have here code EA. This code EA, or the extended code EA, also touches the same common sum point edge. So all the requirements of rule 12 are satisfied, and therefore we can implement here rule 12. And according to rule 12, the following equation will be true. This is point H. That edge D times edge G equals to edge A times edge E. So this is equation 1, and this equation 1 is the implementation of rule 12 in our drawing, the red circle. With again, according to rule 12, edge D times edge G equals to edge A times edge E. Okay. It is very easy to see from the drawing that edge D equals to 12 units in its length. Times edge G. What is the length of edge G? Edge G in total equals to edge D plus DG. Edge D is 12, DG is X, so in total edge G equals to 12 plus X. Repeat again. Edge D equals to 12, edge G equals to 12 plus X, and it is equal to edge A. Edge A is R, it is the radius of this circle, times edge E. Edge E, we already found out that edge E is the diameter of the circle, it is equal to 2R. So in conclusion, according to rule 12, this is equation 1, and according to this equation 1, 12 times 12 plus X equals to R times R. Here we'll divide this equation 1 by 2, and we get that according to equation 1, here 12 over 2 is 6, so this expression in total equals to 6 times 12 plus X. On the other side of the equation we have R times R is 2R squared, and 2R squared over 2 is R squared. Here we divide this equation 1 by 6. And remember that according to equation 1, in this side of the equation we will have 12 plus x. On the other side of the equation we have r squared over 6. Here we subtract 12 from this equation 1. And finally we get that according to equation 1, x equals to r squared over 6 minus 12. Repeat again that x is the variable that we are looking for in this question. X is actually the length of this line segment DG. We have to find out the value of x. Okay. In the next step, we will implement the Pythagoras theorem on this green triangle ADE. So I'll copy this green triangle ADE in this new page and we'll implement on it the Pythagoras theorem. Here by PT is abbreviation for Pythagoras theorem. We have already found out that side A equals to r, is the radius of the circle and also the radius of the quarter circle, of course. We will define one side of this square ABCD as y, therefore AD will be equal to y. AB will be also equal to y according to our definition. BC will be also equal to y. And finally, DC will be also equal to y. Again, here in the right triangle ADE, side AD equals to y. And according to what is given as the question, DE equals to 12. Actually, this is the right triangle ADE that I copied from the original drawing. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle ADE is DE, therefore the square of the hypotenuse is DE squared, and it must be equal to DA squared plus AE squared. DE is 12, therefore DE squared is 12 squared, that is 144. And it is equal to DA squared. DA is y, therefore DA is y squared plus AE squared. AE is r, therefore A squared is r squared. In conclusion, we actually found out that according to equation 2, y squared plus r squared equals to 144. In the next step, we will join points A and C together by a straight line. By joining points A and C, we created here the right triangle ABC. So I copy this right triangle ABC in the new page and we will implement on it the Pythagoras theorem. Here by PT is the abbreviation for Pythagoras theorem. What is the definition of the hypotenuse AC? The hypotenuse AC starts from point A, that is the center of the circle, and then at point C, that is the point of the circle itself. This is exactly the definition of a radius. Therefore, AC is the radius of the circle that is equal to R according to our definition. So the hypotenuse AC equals to R, BC equals to Y, and AB equals to Y. So actually this is the right triangle ABC that I call it from the original drawing according to the Pythagoras theorem in this right triangle ABC. This will be question 3. According to the Pythagoras theorem, AC squared will be equal to AB squared plus BC squared. AC is R, therefore AC squared is R squared, and it is equal to AB squared. AB is Y, therefore AB squared is Y squared, plus BC squared. BC is also Y, therefore BC squared is Y squared. In conclusion, I shall find out that according to equation 3, R squared equals to Y squared plus Y squared, that is 2Y squared. Here we will divide this equation 3 by 2, and finally we get that according to equation 3, Y squared equals to R squared over 2. This is according to equation 3, while according to equation 2, we have already found out that Y squared plus R squared equals to 144. So now we can substitute Y squared in this equation 2, by our equation. This is equation 3 and this is equation 2. So we can substitute Y squared in this equation 2, by R squared over 2 from this equation 3. We will do it now and we will get that according to equation 2. So Y squared is R squared over 2 plus R squared, that is equal to 144. Here we multiply R squared by 2 and we divide it by 2 in order to have a common factor with R squared over 2, and we will get that in the numerator in total we will have R squared plus 2R squared, that is 3R squared over 2 equals to 144. Here we will multiply this equation 2 by 2, and finally we will get that according to equation 2, we get that according to equation 2, R squared equals to 2 times 144 is 288. Repeat again, actually found out that according to equation 2, 3R squared equals to 288. Here we divide this equation 2 by 3. And finally we get that according to this equation 2, r squared equals to 288 over 3, that is 96. So finally, in combination found out that according to equation 2, r squared equals to 96, while according to equation 1, we have already found out that x equals to r squared over 6 minus 12. So actually, now we can substitute r squared in this equation 1, by 96 from equation 2. We do it now and we get that according to equation 1, x equals to r squared, that is 96 over 6 minus 12. 96 over 6 is 16, and 16 minus 12 is 4. In conclusion, we actually found out that x equals to 4 units in its length. Actually, x is the length of this line segment GD. Therefore, GD that is equal to x is equal to 4 units in its length. That is the answer to this question. So we finished with the first method. In the next step, I will present to you how to find out the length of this line segment GD that is equal to x according to the second method. First of all, because of the fact that ABCD is a square, all of its 4 angles are right angles, so this angle equals to 90 degrees in its size. This angle also equals to 90 degrees in its size. This angle equals to 90 degrees. And finally, this angle is also equals to 90 degrees in its size. Again, ABCD is a square. We know that the opposite sides of a square are parallel to each other. So in this square ABCD, side DC must be parallel to the opposite side AB. So I write it down. In square ABCD, DC is parallel to AB. It is true in any square, especially it is true in our square ABCD. But AB is part of the straight line AE. Again, AB is part of the straight line AE. And AB is parallel to DC, therefore, if part of the straight line is parallel to another straight line, then the straight line itself must be also parallel to the other straight line. Therefore, AE must be also parallel to DC. AE is parallel to DC. Those two angles are defined as alternating angles. Again, angle EDC and this angle AED. This angle AED. Both those two angles are defined as alternating angles, and we know that alternating angles between parallel lines are equal to each other. Those two alternating angles are located between those two parallel lines DC and AE. Here AE is parallel to DC, and therefore they must be equal to each other. So those two angles must be equal to each other because of the fact that they are located between the parallel lines DC and AE. But this angle equals to theta, therefore this angle must be also equal to theta because they are equal to each other. Okay. In In the next step, we will do a construction. That is to say, on this point G, we will do perpendicular on AB. Again, from point G, we will do perpendicular on AB. This is a right angle. Again, from point G, we will do perpendicular on AB. So actually, this angle equals to 90 degrees and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point G and AB as N. And we define the intersection point between perpendicular GN and side DC of the square as M. By doing this construction, we created quadrilateral DMAN. Again, we created a quadrilateral DMAN. We know that inside this quadrilateral we have 1, 2, 3 angles. Therefore, this fourth angle must be also equal to 90 degrees in its size, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Okay, so inside this quadrilateral DMAN we have 4 right angles, therefore this quadrilateral it is a rectangle, if not a square. So we relate to this quadrilateral DMAN, it's a rectangle. So this quadrilateral is a rectangle. And here also inside this quadrilateral MC and B we have 1, 2, 3 right angles, therefore this fourth angle must be also equal to 90 degrees, therefore this is also a rectangle. So I write it down. So this angle equals to 90 degrees in its size. Angle DMN, this is angle DMN, that is a right angle. GN is perpendicular, and as a perpendicular it is absolutely a straight line. So GN is a straight line, so if we focus on the left side of this straight line GN at point M, here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the left side of GN at point M? Here we have this angle is the right angle plus the missing angle. In total the sum of the angles, those two angles must be equal to 180 degrees according to the rule that I mentioned. Therefore this missing angle must be equal to 90 degrees in its size. So we have here the small right angle triangle DGM. So I'll copy this small right angle DGM in a new page and we'll analyze it. You should remember that the hypotenuse GD equals to x. X is the variable that we are looking for in this question. This is angle theta. Actually, this is the right triangle DGM that I copied from the original drawing. In this right triangle GDM, it is very easy to see that cosine theta equals to dm over dg. Again, cosine theta equals to dm over dg. What is dm over dg? dg is x, so we substitute dg by x. So according to equation 1, we found out that cosine theta equals to dm over x. We will multiply this equation 1 by x, and we get that according to equation 1, dm equals to x times cosine theta. Okay, this is according to equation 1. In the next step, I will copy this right triangle ADE. In the new page, we will analyze this right triangle ADE. But before that, we will define one side of this square as y. So AD equals to y. AB also equals to y. BC equals to y. And finally, DC also equals to y according to our definition. Now I'll copy this right triangle ADE in a new page and we will analyze it. DE equals to 12 units in its length according to what is given as the equation. Therefore, the hypotenuse of the rectangle DE equals to 12 units in its length. Again, AD equals to y. Only to our definition. What is the definition of side AE? Side AE starts from the center of the quarter circle, that is actually point A, and then to point E, that is the point of the quarter circle itself. This is exactly the definition of a radius. Therefore, AE is the radius of this quarter circle. We will define the radius of this quarter circle as r. Therefore, AE equals to r, according to our definition. And the hypotenuse DE equals to 12, according to what is given as the question. So actually, this is the right triangle ADE, that I copied from the original drawing. So, I forgot to write down, this is angle theta, of course. So, in this right triangle ADE, it is very easy to see that cosine theta equals to AE over DE. So cosine theta equals to AE, that is R, over DE, that is 12. In conclusion, we should find out that according to equation 2, cosine theta equals to R over 12. This is according to equation 2, while according to equation 1, this is equation 1, we have already found out that dm equals to x times cosine theta. Now we can substitute cosine theta in this equation, equation 1, by r over 12 from this equation 2. We will do it now, and we get that according to equation 1, dm equals to x, and cosine theta according to equation 2 is r over 12. In conclusion, we actually found out that dm equals to x times r over 12. So I write it down in the original drawing that dm equals to x times r over 12. This is line 7 dm or side dm that is equal to x times r over 12. But here we already found out that quadrilateral DMAN is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. So in rectangle DMAN, side DM must be equal to the opposite side AN. But DM equals to XR over 12, therefore AN must be also equal to XR over 12. According to the same rule, in the same rectangle, DMAN, side DA must be equal to the opposite side MN. But DA equals to Y, therefore MN must be also equal to Y. In the next step, we return to our right triangle GDM, so we copy this right triangle TGM or GDM in a new page, and we will analyze it. So first, this is the right triangle TGM that I copied from the original drawing. It is very easy to see that in this right triangle TGM, sinus theta equals to GM over DG. So sinus theta equals to GM. GM is the missing side, so we leave it as it is, over DG. DG equals to X according to what is given us in the question. So according to this equation, equation 1, we found out that sinus theta equals to GM over X. In the next step, I'll copy again the right triangle ADE, and we will continue to analyze this right triangle ADE. Side AD equals to Y. And DE equals to 12 units according to what is given as the question. So actually this is the right triangle ADE that I copied from the original drawing. In this right triangle ADE, it is very easy to see that sinus theta equals to AD over DE. So sinus theta equals to AD, that is Y, or DE, that is 12. In conclusion, I actually found out that according to equation 2, sinus theta equals to y over 12. This is according to equation 2, while according to equation 1, we have already found out. Here, we will multiply this equation 1 by x, and we get that according to equation 1, gm equals to x times sinus theta. So according to equation 1, gm equals to x times sinus theta. I'll write it here. Here equation 2. According to equation 1, we have already found out, we just right now found out that gm equals to x times sinus theta. So now we can substitute sinus theta in this equation 1, by y over 12 from this equation 2. We will do it now, and we get that according to equation 1, gm equals to x and sinus theta times sinus theta. And sinus theta according to equation 2 is y over 12. In conclusion, we actually found out that according to equation 1, gm equals to xy over 12. So I write it down in the original drawing that gm equals to xy over 12. In the next step, I will join points A and G together by straight line. By joining points A and G, we get the right angle, triangle AGN. First of all, what is the definition of line segment AG, or the hypotenuse AG? The hypotenuse AG starts from point A, that is the center of the quarter circle, and that's the point G, that is the point of the quarter circle itself. This is exactly the definition of a radius. Therefore, AG is the radius of this quarter circle that is equal to R according to our definition. In the next step, I will copy this right triangle AGN in a new page, and we will implement on this right triangle AGN the Pythagoras theorem. Again, the hypotenuse AG equals to R, this is the radius of the circle or the quarter circle. We have already found out that AN equals to XR over 12. And finally, what is the length of this side GN of the right triangle GN? It is very easy to see from the drawing that GN in total equals to GM plus MN. That is to say, Gn equals to Gm, that is xy over 12, plus Mn, that is y. So in total, Gn equals to y plus xy over 12. So I write it down. So actually, this is the right triangle AGN that I copied from the original drawing. This here by PT is a progression for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the slopes of the perpendiculars. Okay, so this will be equation 2. The hypotenuse on the right triangle AGN is AG, therefore the square of the hypotenuse is AG squared. And AG squared 8g squared. So this will be equation 1 actually. So according to the Pythagoras theorem, in this right triangle Gn, 8g squared equals to an squared plus gn squared. Ag is r, therefore ag squared is r squared. So r squared, and it must be equal to an squared. An is xr over 12, therefore an squared is xr over 12 squared. That is actually x squared times r squared over 12 squared, that is 144. So an squared in total equals to xr over 12 squared equals to x squared times r squared over 124 plus gn squared. Gn is y plus xy over 12, therefore gn squared is y plus xy over 12 squared. Here we take y as a common factor from this equation, and we get that according to this equation, equation 1, r squared equals to x squared times r squared over 144 plus, so here we took y as a common factor, so inside the brackets we have what is left from y after we took from it y as a common factor, what is left is 1, plus what is left from y after we took, what is left from this expression xy over 12 after we took from it y as a common factor, what is left is actually x over 12 and squared. Here we'll open the brackets for this expression, and we get that according to this equation, equation 1, r squared equals to x squared times r squared over 144. So here we have y squared times 1 plus x over 12, also squared. Here we multiply 1 by 12 and then we divide it by 12 in order to have a common factor with x over 12. And we get that according to equation 1, r squared equals to x squared times r squared over 144 plus y squared, and here we have in the numerator, after we multiply 1 by 12, we will have in total 12 plus x over 12 squared. Repeat again. According to equation 1, we actually found out that r squared equals to x squared times r squared over 144. Here it is y squared times 12 plus x over 12 squared. This is y squared times this expression, not plus. Here, according to the algebraic identity, that a over b squared is equal to a squared over b squared, we get that this expression 12 plus x over 12 squared will be equal to 12 plus x squared over 12 squared, that is 144. And we have to multiply it by y squared. plus x squared times r squared over 144 is equal to r squared. This is equation 1. In the next step, we will join points A and C together by a straight line. Actually, before that, we can implement the Pythagoras theorem on the right triangle ADE. Okay, so here we join points A and C together by a straight line. By joining points A and C, we created the right triangle ABC. So copy this right triangle ABC in a new page and we will implement on it the Pythagoras theorem. Here by PT is the abbreviation for Pythagoras theorem. Side AB equals to y, triangle ABC, and side CB also equals to y. The hypotenuse AC, what is the definition of the hypotenuse AC? The hypotenuse AC starts from point A, that is the center of the quarter circle, and ends at point C, that is a point of the quarter circle itself. This is exactly the definition of a radius. Therefore AC is the radius of this is the radius of the circle that is equal to r according to our definition. So actually this is the right triangle ABC that I copied from the original drawing. In this right triangle ABC, according to the Pythagoras theorem, AC squared equals to AB squared plus BC squared. AC is r, therefore AC squared is r squared, and it is equals to AB squared. AB is y, therefore AB is y squared plus BC squared. BC is also y, therefore BC squared is y squared. So in conclusion, I found out that according to equation 2, r squared equals to y squared plus y squared, that is 2y squared. This is according to equation 2. When according to equation 1, we found out that r squared equals to x squared times r squared over 144 plus y squared times 12 plus x squared over 144. This is the two equations that we have here. So actually now we can substitute r squared in this equation 1 by 2y squared from equation 2. We will do it now, and we get that according to equation 1, r squared is 2y squared. This is equal to, here r squared is also 2y squared according to equation 2, times x squared over 144 plus y squared times 12 plus x squared over 144. Now we can divide this equation 1 by y squared. Two y squared over y squared is 2, and it is equals to, here y squared will get cancelled, and we're left only with 2x squared over 144 plus, here y squared will get cancelled, and we're left only with 12 plus x squared over 144. Here we will multiply this equation 1 by 144, and we get that according to equation 1, in this side of the equation we have 2, so 2 times 144 is 288, and here 144 in the denominator will get cancelled, and we left here only with 2x squared plus, here in this expression 144 will get cancelled from the denominator, and we left only with 12 plus x squared. So here we will open the brackets of this expression, and we get that this, according to this equation 1, 288 equals to 2x squared plus 12 plus x squared equals to 12 squared, that is 144, plus x squared, plus 2 times 12x, that is 24x. Here we have actually 288 equals to 2x squared plus x squared is 3x squared, plus 24x plus 144. Here we subtract 288 from this equation 1, and we get that according to equation 1, in this side of the equation 1 we have 3x squared plus 24x, 144 minus 288 equals to minus 144, equals to, here we're left with 0, nothing. So according to equation 1, we actually found out that 3x squared plus 24x minus 144 equals to 0. Here we will divide this equation 1 by 3, and finally we get that according to equation 1, x squared plus 24x over 3 is 8x, minus 144 over 3 is minus 48, is equal to 0. So this is a quadratic equation. X squared plus 8x minus 48 equals to 0 is a quadratic equation. And the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we will find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, that is to say x squared plus 8 x minus 48 equals to 0, the coefficient a equals to 1, the coefficient b equals to 8, and the coefficient c equals to minus 48. So now we have to put the value of a, b, and c for our specific quadratic equation, this quadratic equation, inside this general formula for x, in order to find out the value or the values of x for our specific quadratic equation. I will remind you that x is the length of line segment DG, that is the variable that we are looking for in this question. Now we put the value of a, b, and c, those values, inside this general formula for x in order to find out the value of x for our specific quadratic equation. We do it now, and we get that x equals to minus b. b is 8, therefore minus b is minus 8, plus minus square root of b squared. b is 8, therefore b squared is 8 squared, that is 64, minus 4 times a. a is 1, so minus 4 times 1 is minus 4, times c, that is minus 48. So and minus 4 times 1 is 48, equals to plus 192 divided by 2a. a is 1, so 2a is 2 times 1, that is 2. In conclusion, we found out that x equals to minus 8 plus minus square root of 64. Inside the root we have 64 plus 192, that is 256. So inside the root we have only 256 divided by 2. So actually we found out that x equals to minus 8 plus minus, the square root of 256 is 16 over 2. So here we will have two solutions that are possible for x. One of those two solutions is the negative solution. X equals to minus 8 minus 16, it is definitely a negative solution. And because of the fact that x is the length of this line segment DG, x must be a positive number. It is a length, and the length must be a positive number. So we will cancel the negative solution for x, and we take into account only the positive solution for x. And the positive solution for x is as follows. X equals to minus 8 plus 16 over 2. Minus 8 plus 16 is 8, and 8 over 2 is 4. In conclusion, we found out that x equals to 4 units in its length. Again, x is the length of this line segment GD. So the length of line segment GD that is equal to x is equal to 4 units. And that is the answer to the question according to the second method. So in the next step, I will summarize the lecture. We'll start with the first method, of course. In this lecture, we found out the length of this line segment PD is equal to x. So, in the domain, we have a quarter circle. AFE is a quarter circle. Inside this quarter circle, we have this square ABCD. In addition, we know that this is line segment DE that is equal to 12 units in its length. This is angle GDC that is equal to theta. This is angle EDC that is also equal to theta. Again, I repeat that our mission is to find out the length of this line segment GD that is equal to x. We have to find out the value of x. So here, first of all, we know that ABCD is a square, and we know that all the angles inside any square are right angles, so those 4 angles are all right angles. And so this angle ADC equals to 90 degrees, and this angle equals to theta. Therefore, this missing angle must be equal to the big angle ADC minus theta. So this missing angle ADE, must be equal to 90 degrees minus theta. In the next step, we did a construction, that is to say, we extended line 7GD and line 7EA by straight line until they touch each other. The touching point is here at point H. Okay, and then we extended side CD of this square ABCD by straight line. We define this point as F. I extended side CD. We created here those two vertex angles, and we know that vertex angles are equal to each other. But this vertex angle equals to theta, therefore this angle must be also equal to theta because they are equal to each other. So if we focus on the lower side of the straight line CF at point D, here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of CF at point D? We have this angle that is 90 degrees plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. Therefore, this missing angle, that is to say angle ADF, must be equal to 90 degrees in its size. So the big angle FDA is a right angle. This is angle theta, therefore this missing angle must be equal to 90 degrees minus theta. And here we know that if we focus on the upper side of the straight line BH at point A, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the upper side of VH at point A? We have this angle that is the right angle plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. Therefore, this missing angle must be equal to 180 degrees in its size. Again, in order to complete the sum of the angles in the upper side of VH at point A to 180 degrees, this missing angle must be equal to 90 degrees in its size. In the next step, we proved that those two right angles can go into each other. So why those two right angles can go into each other? First of all, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. In addition, side DA is a common side that belongs to both angles, so we can write down that DA equals to itself as a common side that belongs to both angles. And finally, those two angles are both equal to 90 degrees, therefore they are equal to each other. So actually prove that those two right angles can go into each other according to angle side angle rule. So what is angle side angle rule? Angle side angle rule is that if we prove the two angles and the side that included between the two angles in one triangle are corresponding equal to two angles and the side that included between the two angles in the second triangle, then we actually proved that the two triangles can go into each other according to angle side angle rule. And we proved that those two angles and the side that included between those two angles, that is actually side DA, in this right angle ADE, are correspondingly equal to those two angles. And the side that included between those two angles, that is also the same side DA, in the right angle ADH. Therefore, we proved that those two right angles can go into each other according to angle side angle rule. And from the fact that those two right angles can go into each other, we derive that side DE equals to side DH, according to the rule that corresponding sides and congruent triangles are equal to each other. Those two right angles can go into each other, therefore the two corresponding sides, that is to say DE and DH, must be also equal to each other. So here we conclude that DE equals to DH. But D equals to 12, according to what is given us the question, D equals to 12. So we can write here that D equals to 12, and from this equation 12 equals to D equals to DH, we derive that DH also equals to 12. This is side DH, that is equal to 12 units in its size, in its length. Likewise, because of the fact that those two right angles can go into each other, according to the symbol, we derive that side EE equals to side AH. EE equals to AH. And again, we derive that side AE equals to side AH. What is the definition of AE? AE is the radius of this quarter circle. We define the radius of this quarter circle as R, therefore AE equals to R. According to our definition, AE equals to R, and from this equation R equals to AE equals to AH, we will derive that AH also equals to R. Here AH equals to R. We join point G and E together by straight line. By joining points G and E, we created the triangle E edge G. This triangle G E edge, or edge G E. And then we join points G and A together by straight line. What is the definition of line segment GA? Line segment GA starts from point A, that is the center of the quarter circle, and that's at point G, that is the point of the quarter circle itself. This is exactly the definition of a radius. Therefore, AG is the radius of the quarter circle, that is equal to R according to our definition. So actually, this is point A, and this point A is the circumcenter of this triangle HGE. That is to say, the distance between point A and the three vertices of this triangle HGE that are HG and E are equal. That is to say, the distance of point A from the vertex edge is R, and edge equals to R. The distance, likewise, the distance of point A from the vertex E of triangle HGE is also R, and finally, the distance of point A from the vertex G of triangle HGE is also R. And therefore, point A is defined as the circumcenter of this triangle HGE. In addition, because of the fact that point A is the circumcenter of this triangle HGE, in addition, point A is also the center of the circle that blocks this triangle GHE. And we know that any circle that blocks this triangle HGE must pass for the three vertices that of this triangle HGE that are H, G, and E. Repeat again that the circle that blocks this triangle HGE, its center is located here at point A, and it must pass for the three vertices of this triangle HGE that are H, G, and E. And what is the radius of the circle that blocks this triangle HGE? We know that it must pass for the three vertices HGE of this triangle HGE. And the center is here at point A. So point A is the center of the circle that blocks triangle HGE. Point E is the point of the circle that blocks triangle HGE. Therefore, AE is the radius of the circle that blocks triangle HGE. And we already found out that AE equals to R. So actually, in conclusion, we found out that the circle that blocks this triangle HGE, its center is located here at point A, and its radius is R. That is, and it must pass for points H, G, and E. Those are the three vertices of this triangle G. That is from one side. But from the other side, if we complete this quarter circle to a circle, we get a circle that its radius is R, like the radius of the quarter circle, and its center is also at point A. So we have two circles, one circle that blocks triangle HGE, that is radius is R, and its center is A, and we have also a second circle that can be created by completing this quarter circle to a circle that its radius is also R, and its center is also A. So two circles with the same center and the same radii, they are not two circles, but one circle. They are the same circle. It is the same circle because it has the same radii and the same center. Therefore, we can conclude from what I said here that the circle that will be created by completing this quarter circle to a circle is also blocks this triangle AGE, because those two circles are the same circle. So, and therefore the circle that is completed, that is created by completing this quarter circle to a circle, must pass through point H because it blocks triangle AGE. So the circle, so I draw this, I completed this quarter circle to a circle, and you can see here that the circle passes from point H, that is one vertex of this triangle AGE. It must pass from point H because it is the same circle that blocks triangle AGE. And what is the definition of line segment AGE? Because of the fact that angle AGE, this angle AGE equals to 180 degrees, we know that any angle that is equal to 180 degrees, it is a straight line. So AGE is a straight line, but AGE is a straight line that touches the circle at 2 points, H and E. And therefore AE is a chord, because it touches the circle, it is a straight line that touches the circle at 2 points, H and E. But it is a chord that passes through point A, that is the center of the circle, and we know that any chord that passes through the center of the circle must be the diameter of the circle. Therefore HAE is the diameter of the circle. If HAE is the diameter of the circle, it means that HE is the diameter of the circle. So we can write here that HE is the diameter of the circle. And here we have, in this, we have this angle HGE, this is peripheral angle HGE, that is subtended on HE, that is the diameter of the circle, and we know that any peripheral angle that is subtended on the diameter of the circle must be equal to 90 degrees in its side. So this angle HGE is a right angle. So inside this green quadrilateral ADGE, we have those two opposite angles. They are both right angles. The sum of those two right angles is of course equals to 180 degrees. And any quadrilateral that has two opposite angles that the sum of them is 180 degrees is a cyclic quadrilateral. That is to say, we can block this green quadrilateral ADGE by a circle. So we actually block this quadrilateral by this red circle. Why? Because it can be blocked by a circle, because the sum of the two opposite angles is equal to 180 degrees, and therefore we can block this quadrilateral by a circle. Now we can implement in this red circle rule 12. So what is rule 12? According to rule 12, rule 12 is true in any circle. According to rule 12, if we have here chord AB and the extended chord AB touches the common external point P, and we have the extended chord DC touches the same common external point P. So in this moment, the following equation will be true, that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. We can definitely implement rule 12 in the red circle, because in the red circle we have chord GD, this is chord GD, and the extended chord GD touches the common external point H. In addition, we have the extended chord EA, this is the chord EA, and the extended chord EA also touches the same common external point H. So all the requirements of rule 12 are satisfied, and therefore we can implement here rule 12. According to rule 12, we get that HD times HG equals to HA times HE. Again, HD times HG equals to HA times HE. Repeat again, HD times HG equals to HA times HE. HD is 12, and HD in total is 12 plus X. Repeat again, HD is 12, HD edge G is 12 plus x, edge A is R, and edge E is the diameter of the circle, that is 2R. So in total, I shall find out that according to rule 12, 12 plus x equals to R times 2R. Here we divided this equation 1 by 2, and found out that according to equation 1, 12 over 2 is 6. So 6, this expression in total equals to 6 times 12 plus x, and it is equals to, here we have r times 2r is 2r squared, and 2r squared over 2 is r squared. So in conclusion, we actually found out that according to equation 1, 6 times 12 plus x equals to r squared. Here we divided this equation 1 by 6, and finally found out that 12 plus x equals to r squared over 6. Here we subtracted from this equation 1 12, and finally found out that x equals to r squared over 6 minus 12. And x is the variable that we are looking for in this question. X is the length from this line 7 GD, that is the line 7 that we are looking for in this question. In the next step, actually copied this right triangle ADE in a new page, and we implemented on this right triangle ADE the Pythagoras theorem. This is the right triangle ADE that I copied from the original drawing. Before that, we defined the side of one, the length of one side of square ABCD is y. Therefore, all the four sides of this square ABCD are equal to y, and especially side AD of square ABCD equals to y. So here side AD equals to y. We already found out that AE is the radius of the circle that is equal to r. Here AE equals to r, and DE equals to 12 units in its length according to what is given as the question. According to the Pythagoras theorem in this right triangle ADE, DE square equals to DA square plus AE square. DE is 12, therefore DE square is 12 squared, that is 144, and it is equals to DA square. DA is y, therefore DA square is y square plus AE square. AE is r, therefore AE square is r square. So in conclusion, we actually found out that according to equation 2, 144 equals to y square plus r square. In the next step, we join points A and C together by a straight line. By joining points, we joined points A and C by a straight line. By joining points A and C by a straight line, we created the right triangle ABC. So I copied this right triangle ABC in a new page, and we implemented on this right triangle ABC the Pythagoras theorem. This is the right triangle ABC that I copied from the original drawing. Well, according to our definition, AB equals to y, it is one side of the square, and BC also equals to y, it is one side from square ABCD. And the hypotenuse AC starts from point A, that is the center of the circle, and that's at point C, that is the point of the circle itself. So this is exactly the definition of a radius. Therefore, AC is the radius of the circle, that is equal to r. Here the hypotenuse AC equals to r. According to the Pythagoras theorem, in this right triangle ABC, AC square equals to AB square plus BC square. AC is r, therefore AC square is r square, and it is equal to AB square. AB is y, therefore AB square is y square plus BC square. BC is y, therefore BC square is y square. So in conclusion, we found out that according to equation 3, r square equals to y square plus y square. That is to say, r square equals to y square plus y square is 2y square. So according to equation 3, r square equals to 2y square. We divided this equation 3 by 2, and finally found out that 2y square over 2 is y square, so y square equals to r square over 2 according to equation 3. Y square equals to r square over 2 according to equation 3, while according to equation 2 we have already found out that y square plus r square equals to 144. Now we can substitute y square in this equation 2 by r square over 2 from equation 3. We did it and found out here that y square is r square over 2 plus r square equals to 144. Here we multiplied r squared by 2 and then we divided by 2 in order to common factor of r squared by 2. So in the numerator in total we have r squared plus 2r squared, that is 3r squared, divided by 2 is equals to 144. Here we multiply this equation 2 by 2. So in this side of the equation we left only with 3r squared. On the other side of the equation we have 144 times 2, that is 288. So in conclusion, actually according to equation 2, we found out that 3r squared equals to 288. Here we divided this equation 2 by 3. And finally, we found out that r squared equals to 288 over 3 is 96. So according to equation 2, r squared equals to 96. This is according to equation 2, while according to equation 1, we have already found out that x equals to r squared over 6 minus 12. So now we can substitute r squared in this equation 1, by 96 from equation 2. We did it and found out actually that x equals to r squared, that is 96 over 6 minus 12. 96 over 6 is 12, 96 over 6 is 16, and 16 minus 12 is 4. So actually found out that x, that is the length of this line 7GD, is equals to 4 units. We finished with the first method. In the next step, I actually presented to you how to find out the length of this line 7GD that is equal to x according to the second method. So first of all the 4 angles inside square ABCD are right angles, so those 4 angles are all right angles. And here we have, we know that ABCD is a square, so, and we know that the opposite sides of a square are parallel to each other. So in square ABCD, side DC is parallel to the opposite side AB. This is parallel to AB. This is true in any square, and especially in square ABCD. But AB is part of the straight line AE and is parallel to DC. Therefore, if part of the straight line is parallel to another straight line, then the straight line itself must be also parallel to the other straight line. So therefore AE, that is the straight line itself, must be also parallel to DC. So AE must be also parallel to DC. And those two angles, they are defined as alternating angles. And those two alternating angles are located between the parallel lines DC and AE, and therefore they are equal to each other. So those two alternating angles, they are equal to each other because they are located between the parallel lines DC and AE. But this angle EDC equals to theta, therefore this is angle AED, that is also must be equal to theta. Okay. In the next step, we did the construction, that is to say, from point G, we drew perpendicular on AB. Again, from point G, we drew perpendicular on AB. So this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. We defined the touching point of the perpendicular from point G and AB as N. We defined the intersection point between perpendicular GN and side DC of the square by SM. So inside this quadrilateral that we created here by this construction, that is quadrilateral DM and A, we have 1, 2, 3 angles. Therefore this fourth angle must be also equal to 90 degrees in its size, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So inside this quadrilateral DMAN we have 4 angles. Any quadrilateral that has 4 angles must be at least a rectangle, if not a square. So we relate to this quadrilateral DMAN as a rectangle. Okay, so this quadrilateral is a rectangle. And here we have 1, this right quadrilateral MNBC, we have 1, 2, 3 right angles, therefore the fourth angle is also equal to 90 degrees, and therefore this quadrilateral MNBC is also a rectangle. And if you focus on the left side of the straight line GN is a perpendicular, and it's a perpendicular, it is absolutely a straight line. So if you focus on the left side of this quadrilateral, the GN, at the left side of the straight line GN point M, the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the left side of GN at point M? This is angle, a right angle, and this is the missing angle, so the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. Therefore, this missing angle must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles on the left side of GN point M to 180 degrees, this missing angle must be equal to 90 degrees in its size. So actually we have the small right angle triangle GDM, so I copied the small right angle GDM in a new page and analyze it. This is the right small triangle GDM that I copied from the original drawing. This is angle theta. According to what is given us the question, and side GD, that is the side that we are looking for, equals to x according to what is given us the question. We just right now found out that this angle equals to 90 degrees. So in this right angle GDM, it is very easy to see that cosine theta equals to dm over dg. So cosine theta equals to dm, and dg is x, so substitute dg by x. In conclusion, we found out that according to equation 1, cosine theta equals to dm over x. Here we multiply this equation 1 by x, and finally found out that dm equals to x times cosine theta. So the length from this line dm equals to x times cosine theta. In the next step, I copied this right angle triangle ADE in the new page, and we analyze this right angle triangle ADE. But before that, we defined one side of this square ABCD as y, and therefore all the four sides must be equal to, we define as y, and therefore all the four sides of square ABCD must be equal to y. So this is the right triangle ADE that I got from the original drawing. This right triangle ADE, D equals to 12 according to what is given as the question. AE is the radius of the quarter circle that is equal to r, and AD is one side of square ABCD that is equal to y. So in this right triangle ADE, cosine theta equals to AE over DE. So cosine theta equals to AE, that is r, over DE, that is 12. So in conclusion, I should have found out that according to equation 2, cosine theta equals to r over 12. This is according to equation 2, while according to equation 1, we have already found out that dm equals to x times cosine theta. So now we can substitute cosine theta in this equation 1, by r over 12 from equation 2. We did it, and we found out actually that dm equals to x, and cosine theta is r over 12, so dm total equals to x times r over 12. Here, dm equals to, this is line segment dm, that's equal to x times r over 12. We have already found out that quadrilateral DMAN is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. So in rectangle DMAN, side DM equals to side AN. But dm equals to x over 12, therefore an must be also equal to xr over 12. Likewise, according to the same rule, in the same rectangle dman, side dA must be equal to the opposite side mn. But dA equals to y, therefore mn must be also equal to y. Okay. In the next step, I copied the right triangle DGM in a new page, and we continue to analyze this right triangle DGM. This is the right triangle DGM that I copied from the original drawing. This right triangle DGM, It is very easy to see from the drawing that sinus theta equals to Gm over Gd. Again, sinus theta equals to Gm over Gd. So sinus theta equals to Gm over Gd. Gd is x. So in conclusion, we found out that according to equation 1, sinus theta equals to Gm over x. Here we multiply this equation 1 by x, and finally found out that Gm equals to x times sinus theta. This is according to equation 1. The next step, I copied the right triangle ADE in this new page, and we continue to analyze this right triangle ADE. Side AD equals to y, it is one side of square ABCD, it is equal to y, and d equals to 12 according to what is given in the question. In this right triangle ADE, sinus theta equals to y, to AD over DE. AD is y and DE is 12, so in conclusion, we found out that according to equation 2, sinus theta equals to y over 12. This is according to equation 2, while according to equation 1, we have already found out that Gm equals to x times sinus theta. Now we can substitute sinus theta in this equation 1 by y over 12 from equation 2. We did it and we found out actually that Gm equals to xy over 12. So here Gm equals to xy over 12. In the next step, we join points A and G together by straight line. What is the definition of line segment AG? Line segment AG starts from the center of the quarter circle, that is point A, and ends at point G, that is the point of the quarter circle itself. This is exactly the definition of a radius. Therefore, AG is the radius of the circle that is equal to R. So I copied this right triangle AGN in a new page and implemented the Pythagoras theorem in this right triangle AGN. Here by PT is the version for Pythagoras theorem. This is the right triangle AGN that I copied from the original domain. We just right now found out that the opposite AG equals to R. It is the radius of the circle or the radius of the quarter circle. We have already found out that AN equals to XR over 12. According to the rule that the opposite sides of a rectangle are equal to each other. And finally, Gn equals to Gm plus Mn. That is to say, Gn in total equals to Gm, that is xy over 12, plus Mn, that is y. So in total, Gm equals to y plus xy over 12. Here, Gn in total equals to y plus xy over 12. Here we implemented the Pythagoras theorem on this right triangle G. AN. According to the Pythagoras theorem in this right triangle AGN, AG square equals to AN square plus GN square. And again, AG square equals to AN square plus GN square. AG is R, therefore AG square is R square, and it is equals to AN square. AN is XR over 12, therefore AN is XR over 12 squared, that is actually equals to X square times R square over 12 squared, that is 144. So in total, XR over 12 square equals to X square times R square over 144, plus Gn square. Gn is Y plus XY over 12, therefore Gn square is Y plus XY over 12 square. Here we took Y as a common factor from this equation, from this expression, and found out actually that according to this equation 1, R square equals to X square times R square over 144. Plus here y is a common factor. We took y as a common factor for this expression. So what is left from y after we took from it y is a common factor? What is left is actually 1. And what is left from xy over 12 after we took from it y is a common factor? What is left is actually x over 12 all squared. Then we open the brackets here and found out actually that according to equation 1, r square equals to x square times r square over 144. Here, after we open the brackets, we have here y squared, and here we have 1 plus x over 12 also squared. So in total we have r squared is equal to x squared times r squared over 144 plus y squared times 1 plus x over 12 squared. Here we multiplied 1 by 12 and then we divided by 12. in order to overcome factor x over 12. And we actually found out that here in total in the numerator we will have x plus 12 divided by 12. Then again, according to equation 1, we actually found out that r squared equals to x square over x squared times r squared over 144 plus y squared. And here it's already mentioned that we have here 12 plus x over 12 squared. And according to the algebraic identity that a over b squared equals to a squared over b squared, we get that this expression 12 plus x over 12 squared equals to 12 plus x squared over 12 squared, that is 144. And we have to multiply it by y squared plus x squared times r squared over 144 equals to r squared. This is equation 1. In the next step, we join points A and C together by a straight line. By joining points A and C, we get the right angle ABC. So put this right angle ABC in a new page and we implemented the Pythagorean theorem on this right angle triangle ABC. What is the definition of the hypotenuse AC? The hypotenuse AC of the right triangle ABC starts from point A, that is the center of the quarter circle, and then at point C, that is a point on the quarter circle itself. This is exactly the definition of a radius. Therefore, AC is the radius of this quarter circle, that is equal to R. So here AC equals to R, AB is one side of square ABCD, this is Y, and CB is one side of square ABCD, this is Y. So in this triangle ABC, according here by PT is the version from Pythagoras theorem. According to the Pythagoras theorem, in this right triangle ABC, AC square equals to AB square plus BC square. AC is R, therefore AC square is R square, and it is equals to AB square. AB is y, therefore AB square is y square plus BC square. BC is y, therefore BC square is y square. So in conclusion, we actually found out that according to equation 2, r square equals to y square plus y square, that is 2y square. Repeat again, according to equation 2, we found out actually that r square equals to 2y square. This is according to equation 2. While according to equation 1, we have already found out that r square equals to x squared times r squared over 144 plus y squared times 12 plus x squared over 144. Now we can substitute r squared in this equation, equation 1, by 2y squared from this equation, equation 2. We did it. We found out that according to equation 1, r squared is 2y squared. And it is equals to, again, r squared is 2y squared times x times x squared over 144 plus y squared times 12 plus x squared over 144. Here we divided this equation, equation 1 by y squared, and we found out that in this side of the equation 1 we have 2y squared over y squared is 2, and the other side of the equation we have y squared. This expression that it will get cancelled, and we left only, without cancelled y squared, we left only with 2x squared over 144. We cancelled y squared in this expression also, and we left only with 12 plus x squared over 144. Here we multiplied this equation, equation 1 by 144, and actually we found out that according to equation 1, 2 times, in this side of the equation we have 2, so 2 times 144 is 288, and here we have the denominator 144, so after we multiply it by 144, the denominator 144 will get cancelled, and we left here only with 2x squared, and here the denominator 144 also get cancelled, and we left only with 12 plus x squared. So in conclusion, according to equation 1, we actually found out that 288 equals to 2x squared plus 12 plus x squared. Here we open the brackets of this expression and actually found out that according to this equation, equation 1, 288 equals to 2x, here 288 equals to 2x squared, and 12 plus x squared equals to 12 squared, that is 144, plus x squared, plus 2 times 12 times x, that is 24x. So we have here 288 is equal to 2x squared plus x squared is 3x squared plus 24x plus 144. Here we subtracted 288 from this equation and finally found out that according to equation 1, 3x squared plus 24x. Here we have 144 minus 288, that is minus 144. In conclusion, we found out that according to equation 1, 3x squared plus 24x minus 144 equals to 0. Here we divided this equation 1 by 3 and we found out that according to equation 1, 3x squared over 3 is x squared, 24x over 3 is 8x, and finally minus 144 over 3 is minus 48. So we got here a quadratic equation. X squared plus 8x minus 48 equals to 0. It is a quadratic equation. And the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, the coefficients a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula: x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. Now as a specific quadratic equation, that is to say x squared plus 8x minus 48 equals to 0, the coefficient a equals to 1, the coefficient b equals to 8, and the coefficient c equals to minus 48. So we have to put the values of a, b, and c from our specific quadratic equation, this quadratic equation in this general formula for x, in order to find out the values of x for our specific quadratic equation. I will remind you that x in our quadratic equation is the length of this line 7 GD is equal to x. We have to find out the value of x, that is the length of line 7 GD. So we put the values of a, b, and c from our specific quadratic equation, this equation, in this general formula, in order to find out the value of x in our specific quadratic equation. And we found out actually that x is equals to minus b, b is 8, therefore minus b is minus 8, plus minus the square root of b squared. B is 8, therefore b squared is 8 squared, that is 64, minus 4 times a. A is 1, so minus 4 times 1 is minus 4, times c, that is minus 48. And minus 4 times minus 48 is plus 192. So inside the root we left only with 64 plus 192 divided by 2a. A is 1, so 2a is 2 times 1, that is 2. In conclusion, we actually found out that x equals to, inside the root we have 64 plus 192, that is 256 divided by 2. So x equals to minus 8 plus minus the square root of 256 is 16 divided by 2. So here we have two solutions that are possible for x. The negative solution is an irrelevant solution because of the fact that x is the length of line 7 GD, and x as a length must be a positive number. So we'll take into account only the positive solution for x, and the positive solution for x is x equals to minus 8 plus 16 over 2. Minus 8 plus 16 is 8, and 8 over 2 is 4. In conclusion, actually found out that the length of this line 7 GD that is equal to x is equal to 4 units. Okay, thank you very much.